All right, so now we're moving on to some new definitions. So when we talk about a column vector or a vector, and here we're talking about a vector, and the way we say this is R2. So R2, and this is R3, and this is Rn. Okay, so vectors in R2 are 2 by 1s. So 2 rows, 1 column. So these are 2 examples, and here are vectors in R3. So they're 3 by 1, right? 3 entries. And Rn, and so we're going to get used to putting dots. All right, so if I want to add vectors, they have to be the same size. They have to be 2 by 1s together, and then we can add them. If I want to multiply a vector by a scalar, the scalar is a constant, so c is any real number. So if I multiply the number c times the vector v here, then what I'm doing is taking c times each one of the entries. Oops, a little typo there. Should be a c here, right there. There we go. All right. So if I have a linear combination, if I have a set of vectors, v1, v2, comma, up to vp, and then a set of scalars, all these different letters c representing numbers, then the vector y can be represented as a number times a vector plus a number times another vector. This is called a linear combination of these vectors with these weights. So all these constants are called weights. So this is a really important idea. So we're going to be talking about linear combination a lot. All right, so let's go through lots of different little examples just to get the idea. So this question here is, with this vector 1, 0, a linear combination of these 2 vectors. So what I'm asking is this true that I can have one number times this vector and another number times this vector? Can I figure out what these c's would have to be equal to? So there's lots of different options, but what if I let c1 equal 1/2 and let c2 equal 0? Of course, this is not unique, but this is just getting the idea across that this vector is a linear combination of these 2 vectors. All right, let's look at this one. Is this vector here a linear combination of these 2 vectors? And by looking at where their entries are, I can say no. I cannot get to this vector from a linear combination of these 2 vectors. All right, let's look at this one. 1, 2, 0. Is it a linear combination plus c2, 0, 3, 0? I think I can see it, and I really have made these as easy as possible so that you could do them by hand, just by eyeballing it. It's not always going to be the case, right? So if I let c1 equal 1/2, and then c2 equal 2/3, this would work, right? All right, how about this next one? Is this 0, -2, 3, a linear combination of these vectors? 1, 0, 0 plus c3, 0, 3, 0. So a linear combination. So is this true? Can I get to this vector here from a linear combination of these vectors here? I think not. So can you see I've got this entry right here, and each of these vectors have a 0 in the last entry, so there is no way that I can get a 3 in this last entry from linear combinations of those vectors. Okay, so hopefully you've got the idea of linear combination. So let's move on to this next example in the next video.